book, picture this: a doctor in a remote clinic needs an AI to diagnose a rare disease, but there's barely any data available. Or a business wants to build a smart tool for a niche problem without the luxury of millions of examples that the tech giants have at their fingertips. For decades, creating robust AI models meant feeding them oceans of labeled data. But now, a scientific leap has rewritten the rules. We're about to uncover how AI can learn from just a handful of samples by taking a shortcut that's changing the entire field. Topic introduction. Today, I'll reveal a technique that's transforming how we build smart systems, a way to train high-performing AI models with almost no data. Traditionally, deep learning was synonymous with big data, but what if we could tap into models trained on gigantic datasets, then rapidly adapt them to completely new situations with minimal information? This is more than recycling knowledge, it's about transferring deep, abstract skills across tasks and domains, a concept known as transfer learning and its radical extension, few-shot adaptation. Core concept explained. Here's the genius trick: instead of training a new model from scratch, researchers start with a model trained on a massive, general-purpose dataset like billions of internet images or pages of natural language. This pre-trained model has already learned to detect general structures, patterns, and concepts in the world. The breakthrough comes when we ask it to learn something entirely new, like recognizing specific medical images or classifying legal text, using perhaps only a dozen new examples. How? At the heart of this technique is the idea that the early layers of modern AI systems learn features that are surprisingly universal: edges and shapes in images, grammar and facts in language, while the later layers can be tweaked to focus on the specifics of a task. By only fine-tuning a small part of the model, or giving it a tiny number of labeled examples, sometimes astonishingly, just one or two, we unlock the model's prior knowledge and let it rapidly specialize. One of the most stunning twists in this story comes with advanced techniques like prompt-based learning in language models. Here, you don't even always need to update the model itself, you just cleverly rephrase your question, guiding the AI to use its vast built-in knowledge for your custom task. In images, adapter modules or task tokens allow the model to graft on brand new abilities without ever retraining everything from scratch. Use cases: the impact is enormous. In medicine, this shortcut allows specialists to build diagnostic tools for rare diseases where annotated scans are precious. In law, it means AI can tackle obscure regional legislations quickly for small client bases. Smaller companies can now harness state-of-the-art machine learning for highly specific applications, from identifying manufacturing defects with scanned examples to analyzing the sentiment of slang-laden text from a new online community. Even more urgently, during emergencies like new pandemics, scientists build detection tools in days, not months, by swiftly adapting AI trained on past diseases. And in developing countries or niche sectors, innovation is no longer bottlenecked by data scarcity. The model learns to see, read, or diagnose in a brand new way without waiting for a data tsunami that may never arrive. Importance: this is bigger than a clever shortcut, it levels the playing field. For years, only organizations with massive data collection empires could play the cutting-edge AI game. Now, anyone with a strong idea and a handful of examples can teach an AI new tricks. This democratizes machine learning, supercharges innovation, and allows swift responses to the world's most urgent and unique challenges. It's not just about making do with little data, it's about standing on the shoulders of giants and moving faster and further than ever before. Q&A. Question: what kinds of tasks benefit most from this approach? A. Nearly any task where data is scarce or expensive: medical imaging, legal analysis, specialized industrial inspection, regional language processing, rare event prediction, and much more. Question: does this mean big datasets are obsolete? A. Known huge datasets are vital for building the foundational models. But with this technique, adapting those foundations to new, specific tasks requires only a fraction of the data and effort. Question: are the results as reliable as training from scratch on mountains of data? A. Often yes, sometimes even better, especially when data is scarce. The pre-trained model brings a trove of general knowledge that pure small data training simply can't match. However, for some very unique tasks, extra care or creative adaptation may still be needed. Closing: in a world where data is often out of reach, this technique cracks open new frontiers. It means that AI's future isn't just for the giants, it's for everyone. The power to teach machines with almost no data? That's a breakthrough shaping the future of technology.